Okay, sorry for the long delay. And we get an echo, of course. That's what's called. Okay. Web3, yay. Okay. Don't be scared by the number 3 if this is your first SIGPwny meeting. Everything should be pretty independent from Web 1 and 2. So as long as you know about how general web works, then you should be okay. So let's get into it. Oh, down. I hate this. Okay. Announcements. Our first seminar meeting is on Sunday, this Sunday. So everyone here should be here. It's the first one. So you gotta be there. Everyone not here should also be here. So you're in Zoom. I see one person in Zoom. You're gonna be there. All right. And next Friday is our first CTF of the semester, LA CTF. Fun fact about me, I'm from LA. I didn't get to meet the people who are running it because of the LA fires, but I met them online. They're very cool. This should be one of the best CTFs of the year. So make sure you're there too. Next Friday starts at 10, which I know is late. I don't know why they started so late. Mhm. It's all the normal categories. There'll be web, phone, crypto. I think they did forensics last year and OSINT. So if you know those challenges, but yeah. Nope. Yeah. Yeah, just show up and we'll give you creds and then that's it. I don't, probably. There always is. Yeah, there always is. It's 10 p.m. though, so like it's gonna be a very late dinner. All right, here's the meeting flag. Somewhere in Siebel, we don't know. We have to basically just show up because we can't. Yeah, we'll put us in Discord once we figure it out. I'll give you guys a minute. Web3 meeting flag. Yeah, everything is unsafe. You'll see like everyone knows that you can't trust the front end, but like you also can't really trust the back end. Like the whole stack is cooked. Okay. But like if you use JavaScript or Python, everything is like unsafe. Everything, especially Python. Yeah. Go is pretty safe. So yeah, or C. Okay. So we got 4 types of vulnerabilities today. They're all on the back end. So I'm not going to read them. We're going to go over them all. Command injection. All right. So what happens is whenever you use user input to execute a shell command and don't sanitize that user input, then you get command injection. You'll see some examples of that. So this sounds kind of weird. You're like, why are you executing user input in a shell command? But it's pretty common for tools that rely on a shell, like a shell script to do something. So if you've ever used like a web tool that downloads something off of YouTube, that's probably just running a a shell tool called like YouTube download or something like that. And very often they'll give you access to those some arguments to that shell command, like the URL of the video. So if you don't sanitize that input, you might be able to break out and then start running whatever shell command you want. And so it's similar to SQL injections because like SQL injections, it's usually you just insert a quote and then you can start running some unrelated code. Not SQL, but this time shell. Yeah. And yeah, just like basic bash stuff will work here. So if you want to run another command, you can use and or semicolon. So yeah, know your bash. All right, here's an example. So there's a little program called Calce that will take in like a string of letters, and then it'll make a little ASCII art of a cow saying those letters. So here it makes sense. You have like a little web service that all it does is it runs cow say and then gives the user like the ASCII art that it generated from the input. Seems safe enough, but no, because you can just put in a double quote and that escapes. Like here you can see we wrote hello and then a double quote, and now we're just in like normal bash. So we could do and to run another command and then cat the flag, which is shorthand for like you could do anything. You could delete rmrf/, you could like get the passwords or whatever you can do in bash, which is pretty much anything. So you can see we printed the flag here. So this one's pretty easy. I think it's pretty simple to understand what's going on, but you'll see this a lot. Probably one of the more common vulnerabilities if the language itself doesn't make it harder to implement. All right, template injection. This one's also pretty common. All right, so if you don't know what a web template is, it's similar to, imagine an HTML file with little bits of code you see in these like double braces here. That's just like a Python variable that gets passed in here and it gets replaced. So whenever you see double brace title double brace, what will happen is this render template function will take this HTML file and replace everything in these braces with the value of title. So it's useful. I think it's pretty common when you're writing a web app that you might want to have some sort of like interactive part or something that updates. Like if you had the date on your website and you wrote a raw HTML file, it'd be really annoying every single day to have to update it for the next day. Like that wouldn't make any sense. So entirely on the server, you could use templates to automatically update it. Like in Python, you fetch the current day and pass it in. This is pretty common for like basic web apps without having to use JavaScript. So yeah, they usually express or allow statements and expressions. And you can see with the like brace percent syntax for statements, these are a little harder to understand and they depend more on like the specific templating tool you're using. We're showing Jinja, which will allow certain things to go in these, like you can do if-else blocks in these statements. And the easier to understand double brace is an expression. You can see like 7 times 7 is an expression. This is the common one you'll see for if you look up template injection. They'll always test out double brace 7 times 7. And then if you see in the output 49, you know that they have like a critical error somewhere in their app. And then I'll explain what that request object is. But you can do other things besides just accessing numbers. Sometimes they'll give you access to certain objects, which if you came to the PyGel meeting, you'll know access to pretty much any Python object gives you access to everything in Python. If you're allowed to run like the dot, so you can do like request dot something to get attributes and you can call functions, just having access to an object, get adder, and then function call is enough to do complete remote code execution. You can do whatever you want. You can run shell commands. You can get any variable in the Python scope. So we'll see. Yeah, so like in the expressions we're talking about, they expose two objects, the Flask config and then the request object, which I think you could imagine both of those are useful. Like if you want to just put something from your config into your app, you'd want access to the config. And also if you want to have some data related to the request, then you'd need access to it. But Python magic lets you, again, if you came to the PyGel meeting, you'll see the globals, which is basically every single thing in the global Python scope, like all the built-ins, every variable you define, or I guess every variable they defined in this request.application. And you'll see all of them in the next slide. But there is some like subtlety to what actually is the vulnerability here. So it's not, if you're having user input that gets passed into your template, like I showed 2 slides ago, or 3, like anything you put in these quotes here, even if it's user provided, that's not a vulnerability if you're only running the template once. But if the user gets to actually control the template itself, like we're showing in this example, they're controlling what gets passed into the first argument, which is the actual template string, then that's the vulnerability. So you'll see user input are getting injected into the template. Oops. So after the string concatenation, you see, this is before rendering the template. We already have this brace 1 plus 1. Which means after it gets rendered, it's gonna get replaced. Sorry if I didn't show it, but after it gets rendered, like right here will be stick around, comma, and then 2. So it will have executed your code, which means it could do something malicious too. Okay. So it's pretty common to put secrets in your this is Jinja or Flask config. So if you did have a secret in your Flask config, then literally just doing config.items gives you everything in the config, and then you've exposed your secret key. It's like an API key or something. And we can also just get full shell commands. So as I said earlier, this globals has every single variable in the global scope, which Python exposes a thing called built-ins, which you don't have to know about too much. If you came to PyGL, you'll know what that is. But built-ins allows you to import, and then in these quotes here after system, that could be any shell command. So that could be the rmrf / or whatever else you want to run, cat / etc / password, whatever. Yeah. And this is the global. I'll give you a second to read, but you can see there's a lot. Like you can see built-ins is in there, import is in there. If you've done PyGL, you know you have eval and exec, which are bad. You have breakpoint somewhere in there. So yeah, just giving access to this request object made it very easy to do complete RCE, just off of like a pretty simple mistake. You can see like, this is pretty subtle. I don't think you see this and you're like, oh, this is remote code execution, but it is. And this isn't, I just showed Python as the example, but pretty much any language that has templates will have template injection. So this one isn't just a Python thing. It's kind of like a template injection. It kind of works the same way where if you're controlling the like string part of the format, like the first part, like here, this is like the first argument that gets passed into the format string. Like if you have access to this part, that's like really bad. You can do anything. And that's even an issue in Python. Python has format string vulnerabilities, not just C. All right, path traversal. This is probably the easiest one and also the most common. I forgot which major security firm like talked about this as like super sophisticated hacking, and it was just path traversal. So yeah, maybe look that up. But this is like big deal stuff. Because I said here, it can get you access to like any file on the system, which is probably like the second worst exploit you could have short of like complete remote code execution, but you can read every single file in the system just because a pretty basic mistake. So yeah, if you haven't seen Unix paths, we have absolute paths, which the first character is the slash, and then relative paths where the first character is the dot slash. And then 2 dots means go up 1 directory. So you can have paths like this, which you go forward 2 directories and then go back 2 directories. So we're back at slash. And then you can keep going from there to access any file in the system. So here's like secret files / flag.txt. Any file you have permission to read, I guess. So yeah, here's an example of where someone might write this is they have a little web server that's just supposed to serve up images. And they might think because they started their os path.join path with this / my lovely images, then like whatever comes after it is going to be at least a subdirectory of that. So like there's nothing sensitive in that folder. So it looks fine to do this. But as we know, you can just prefix your path with .. to go up 1 directory. And now you can read from the base path and read /etc / password or any other file in the system that user has access to. Yeah, pretty bad for something. To me, I wouldn't think this is, I can read every file in the system. Seems pretty innocuous, but no. All right, SSRF was the last one. All right. So if you have a server that is making requests on behalf of the user to fetch something, and I'll show an example later, but you can see just a list of some. So like HTML to PDF / image renderers. So like you give it a link and then it will render it as a PDF, like a tool like that, or a link preview generator that again is fetching from the internet and then giving like a little preview for that web page and some other stuff. There's a lot of websites that take in like a URL from the user and this will spit back some sort of information about that web page. And the idea behind it is because you're getting the web server to issue the request, now you can access things on the web server's network that you don't have access to. So you can see this server right here on 10.0.0.1, the private IP address, so the attacker doesn't have access to it. If they made a query to this, it would just send them that port on their own network, so it's not helpful for them. But because they can get this xyz.com to issue the request and give them the response, they're able to access this website, which in this case is an admin panel that you're not supposed to have access to. But because you're able to get the web server to issue the request, now you have access to it. And the whole point of their firewall was broken. All right. So yeah, I think like the pretty basic problem you could see with this is you don't know where things are stored. So like if you don't know what address the whatever like random servers that you want access to on the local network are running at, then you wouldn't be able to set it up. But there's some ways to get around it and like network enumeration. So you just hit a bunch of random IP addresses, or maybe you have a list of some common ones and you just hit them one by one until you find something sensitive. And this is pretty cool. You can do local file inclusion. So you're able to, like the last thing we saw, the path traversal exploit, you're able to see random files on the compute on the server because of this file : / protocol, which lets you, it just like when it fetches a file, it just returns the contents of that file, and now you can see it, even though it's not running on like a server. And some cloud services like AWS here expose a REST interface, which is just a HTTP interface that now you have access to because you can get the server to make these requests for you. And then you can get config details about their AWS or even auth keys, which they can use to, I don't know, start mining crypto or something on their account. And then finally, whatever database they're using, like Postgres, might supply an HTTP interface, which now you can make requests to, and then maybe read some data from their database or modify it, give them a big ransomware bill. Happened to me. All right. So here's a little mock server in Flask. All it does is you give it a URL, and then it makes it a GET request to that URL, and then gives you the text content from that URL. Which again, this seems kind of stupid. You're like, why would you do this? But in the context of a tool like a service that takes a link and then makes a PDF of that website, can be more reasonable to want to have to get the contents of that website. But as you can see here, we could just, instead of giving a URL for something on the outside internet, we can give a local IP address, which all this code will do is run that HTTP request. And there's nothing blocking you from doing things that are internal. And then now we have access to the internal service. All right, I talked about this earlier, but our first seminar meeting is on Sunday. Again, everyone here should go. Everyone not here should go. I think the last time we ran one of these was like in 2021. So pretty much everyone on the team has not gone ever. So make sure you're there. And I wrote up all the challenges that are here. I want to highlight Meme Machine specifically. The PDF for these slides aren't up yet, but once they are, this link will pretty much just give you the answer. So don't look at it until you try, get stuck, and then need some help. Because yeah, it's kind of broken URL. And the rest should all be pretty reasonable, except again, I highlighted here, but word counter 3 is dependent on you solving word counter 1 first. You won't be able to even like access the challenge. Oh, yes. Uh, I think all of these, we give you the source code of the server. So just look at what language the source code is. But otherwise, you're talking about command injection. Uh, yeah. If you don't know the language of the server, then you just have to like spam random languages until you get it. There aren't that many to try. It's like at most like 6, I'd imagine. But also you could check in like the Chrome dev tools or whatever dev tools you're using. Oftentimes the server will like there'll be a little HTTP header on the response that says what server it's running. Like Flask specifically will tell you. So if you see that, then you know they're running Python. Yeah, I have it. Yeah, you can look it up. There are plugins that'll tell you. Yeah, well, something like that. Oh, yeah. And yeah, word counter 1 is a SQL injection. It's pretty easy. I think almost if you came to web 2, then you'd be able to solve it like immediately. Otherwise, I would skip word counter. All these other ones are good enough. Especially like tux.tv is probably the hardest one on the list. So if you finish that, then you'd be able to do word counter 3. So yeah, no worries if you don't know SQL injection. No, it's all Python. Oh, these are command injection. What am I saying? The command injection ones, no, none of them are PowerShell. They're all Bash. No, I don't think yeah, there's no Windows. Yeah. Also, yeah, you'll see in SSRF4, there's a secret SSRF5, which is down. So if anyone finishes all 4 SSRF challenges and wants to do SSRF5, tell me and I'll open it. And also, if you have any questions for any of these, last night I redid all of them to make sure they're working. So I have the answer on the top of my head. So that's it. Here's the meeting flag again. Ooh.